Today our discussion will be on osmosis and osmotic pressure. You know, when a solvent is separated from a solution by a semi-permeable membrane, then only the solvent molecules will pass through that semi-permeable membrane from the solvent compartment to the solution compartment, or from a dilute solution to a concentrated solution, in order to dilute the concentrated one. This process is called this process of passage of solvent from the dilute solution to the concentrated solution, or from the solvent part to the solution compartment through a SPM, is called osmosis. Remember, semi-permeable membranes are a kind of membrane, special kind of membrane, which will allow only the solvent molecules and not the solute molecules to pass through them. That is the meaning of semi-permeable membrane. Now, due to the passage of solvent molecules from the solvent to the solution compartment, what will happen? After some time, the level of the solution in the solution compartment will increase, and the level of the solvent compartment will decrease through the process of osmosis. Now, what about the meaning of osmotic pressure? Very simple. Osmotic pressure means minimum pressure needed to stop osmosis. Means over here, if you exert pressure, the minimum pressure needed to stop osmosis will be called osmotic pressure. Now, that osmotic pressure, it's true that osmotic pressure denoted by pi depends on temperature, better to say absolute temperature. Osmotic pressure depends on concentration C. Thus, osmotic pressure of a solution is directly proportional to the absolute temperature when concentration remains constant. Again, osmotic pressure pi is directly proportional to the concentration when absolute temperature or temperature remains constant. This is according to Van 't Hoff's law of osmotic pressure. So, according to Van 't Hoff's law of osmotic pressure of a solution is directly proportional to the absolute temperature when concentration remains constant, and second law is osmotic pressure of a solution is directly proportional to the concentration when absolute temperature remains constant. So, combining both the laws, we can write pi is proportional to C into T. Therefore, pi is equal to constant of proportionality KCT. Means we can write K into C means N by V, number of moles per unit volume, into T. Therefore, pi V will be equal to K or NKT. Now, it has been found out that the value of K is 0.08205 liter atmosphere per mole per Kelvin. Means the value of K is equal to the value of the universal gas constant R. Therefore, we can write ultimately it becomes pi v will be equal to nRT. Ultimately pi will be equal to n by VRT, means we can write CRT, where pi is the osmotic pressure of the solution, C is the concentration of the solute. Remember, the solute should be non-electrolyte. R is the universal gas constant having the value like 0.08205 liter atmosphere per mole per Kelvin, and T is the absolute temperature. Now it's true that if the solute dissociates or associates, obviously at that time it will be pi will be equal to ICRT, where I is called the Van 't Hoff factor. And I told you how to find out the value of I in case of dissociation or in case of association. Now, regarding that osmotic pressure, you have to remember some terminology. You have to know the meaning of exosmosis or exosmosis. From the name it is clear to you that exosmosis means when the solvent molecules come outward of the cell, at that time that will be called exosmosis. On the other hand, if it is endosmosis, means the inward flow of solvent molecules will be called endosmosis. Next, you have to know the meaning of reverse osmosis. Reverse osmosis means, always it's true that in general that solvent molecules in the process of osmosis will pass through that semi-permeable membrane from solvent to the solution compartment. Solvent molecules only. And or you can say that solvent molecules pass from the dilute solution to the concentrated solution. Now I told you the meaning of osmotic pressure. Minimum pressure needed to stop osmosis means at that time you have to exert that osmotic pressure. Minimum pressure pi means that osmotic pressure will be stopped by exerting an equal pressure from this side. Now, interesting point is, if we exert more pressure than that osmotic pressure, means if more pressure is applied at the solution compartment, at that time there will be osmosis, but at that time only the solvent molecules will pass from the concentrated solution to the dilute solution or from the solution compartment to the solvent compartment. This process is called reverse osmosis. Means by exerting pressure, the solvent molecules will pass through the semi-permeable membrane from the concentrated solution to the dilute solution or from the solvent compartment, solution compartment to the solvent compartment by exerting pressure, and that pressure should be more than the osmotic pressure of the solution. At that time that process will be called reverse osmosis. All of you have that idea that by reverse osmosis process today different kinds of water filter function. At that time we get almost pure water by the process of reverse osmosis. Again you have to know another terms that is called actually this kind of classification is made on the basis of osmotic pressure of two solutions, means osmotic pressure of two solutions are compared. If the osmotic pressure of a particular solution is more than the other, if the osmotic pressure of a solution is more than the other, then this solution will be called, this first solution will be called hypertonic with respect to the second one. On the other hand, if osmotic pressure is of a solution is less than, osmotic pressure of a solution is less than the other, then the first solution will be hypotonic with respect to the second solution. And if it happens that the osmotic pressure of both the solutions are same, at that time that solution will be called, both the solution will be called isotonic solution. All of you know that 0.9% sodium chloride is isotonic to human blood. Means 0.9% sodium chloride solution, its osmotic pressure and the osmotic pressure of blood will be equal. Let's find out what about the exact value of, or very close value of, osmotic pressure of blood. Let us do the calculation. Very simple calculation. Look at 0.9% sodium chloride means you can say 100 cc solution contains 0.9 gram sodium chloride. So 1000 cc. Why 1000 cc? 1 liter. So it will be 0.9 into 1000 divided by 100 means it will be 9 gram sodium chloride, means it will be 9 divided by 58.5 gram formula weight NaCl. Now you know that sodium chloride in solution, it is an electrolyte. In solution it dissociates into Na plus and Cl minus. So at time t0 means initially the number of mole will be 1, at the initial point it will be 0, after time t means after the dissociation it will be 1 minus alpha. Alpha is the degree of dissociation and it will be alpha and it will be alpha. Therefore Bantam factor will be 1 minus alpha plus alpha means it will be 1 plus alpha. Now it's true that if it happens that sodium chloride, suppose it dissociates by, suppose 90% or 95%, suppose it dissociates by 90%. If alpha is 90%, at that time that I will become 1 plus 90% means 90 divided by 100 means it will be 0.9 means it will be 1.9. So using that formula, pi is equal to ICRT means it will be I into C means N by V into RT. So here look, I will be 1.9, N by V means number of moles will be 9 divided by 58.5. V is as usual 1 liter, volume is, look at here, it is 1 liter, and R is 0.08205. Obviously that unit of pi will be atm, and temperature, suppose the temperature is 37 degrees centigrade means 310 Kelvin. So at that time you will get that osmotic pressure almost 8.2 atm or something like that. That is the osmotic pressure of blood. That is the osmotic pressure of 0.9% sodium chloride, and that's why these two solutions are called isotonic to each other.